He will talk about the growing concerns about risks involved in using US-based cloud service providers. And he sent PowerPoint. No, but right, and this from a GDPR perspective. I find this quite interesting because we had a long fight with the university about moving to Office 365, which we lost. So all the student data actually is on some cloud service, which is in Ireland, but I think we will hear that this is for sure no problem at all.
Thank you. I see the formatting is a bit different, font size, but we'll manage. Yeah, just as a short introduction, who am I? I have a technical background. I used to work at the Dutch Data Protection Authority. Now I do a lot of data protection impact assessments, as they're called formally. We basically investigate for our customers like big cloud services, software packages, to see if they comply with the GDPR and relevant laws, and if there's any risks for the data subject, so the people using the software and the people whose data is being processed in the software. So the scope, the talk, like everything is cloud. Right now, like everybody is dependent, and even if it's not cloud, it's mostly US software vendors, at least somewhere in your supply chain, even if you're using like European software, European services, it's still Windows, Office. So these international transfers that come along with these international software vendors and service providers, they're everywhere, they're a big problem. So there's lots of areas to think about and be careful about. Just to scope the conversation, this is not what I'm going to talk about, like the ICC, basically like the report. I guess everybody read it. The US had sanctions on one of the prosecutors of the International Criminal Court, so he can't use his mailbox anymore, basically. I get this is a really like important concern, and it's quite complicated to figure out how this exactly works. Like, did Microsoft kick him out? Did they ask the ICC to kick him out so they don't have to kick out the entire ICC? I don't know exactly what happened. My formal response to this is not a European institution, so it's out of scope. We do like EU data protection stuff, but that's a boring answer. It's still irrelevant, like it's a sign for a relevant concern, like governments enforcing like influence on vendors affecting other organizations. So while this specific example might not be the concern for us, it's still a good example to think about. Like, what do you do when the US starts to influence or continues or changes how they influence, for example, Microsoft or other big software vendors? So what do? We have, like, this is an article from the New York Times about Shura, my colleague, who I do most of my work with. And like this title is a bit of like a caricature of what we do. But I think it gives some nice context. Because formally what we do is write the DPIA, like a big report with investigation, like how does the software work, how does the servers work, what's being logged. We dive into the technical details, the legal aspects. But those reports by themselves are quite, I think, boring. It's how do you use it to actually change things. And for me personally, and I think for most of our customers too, it's a balance between making sure that the software and the service you depend on has as little risk as possible for data subjects, but also making sure that if stuff does go wrong, there are alternatives. So you need to find that balance. So if the US goes crazy with their measures, with their influence, we have alternatives. So you see, we looked at Google, Microsoft, Zoom, especially like in the COVID period. We checked out different video conferencing solutions because you want to be able to switch. At least our customers want to be able to switch. Another part of this is that at least quite a few of our the biggest customers publish our work to make sure that we have impact. So we don't write a report that ends up like in some drawer somewhere to be ignored by the institution. And because it's published, first of all, everybody can criticize our work if we miss something. That's like nerve-wracking, but that's great to have. But also it increases the impact. If there are findings, everybody will read it, and the vendor has extra pressure to change their product or their service. So in that whole combined approach, not just writing a report, but also the process around it, I think we have some more influence on these big vendors than maybe other organizations have. So I like this public approach, like everything is public, all our findings, at least for these few customers. And it has impact. I know not everybody agrees that we have enough impact. Some people want to move away from Microsoft entirely. But for me, it's important, improve what you can't move away from and look for alternatives. So what I like to do, when I talk to a technical crowd, I like to force you to listen to some legal background, and vice versa. I always live in the middle. So what are data transfers exactly? What's in what framework do we live? Under the GDPR, you basically have 4 levels of allowed processing. The most obvious one is processing inside of the European Economic Area. That's fine. There's no special rules for that. GDPR applies, period. Then there's countries where the European Commission has said, okay, the laws in that country are similar enough, basically the similar protection level. So we put a stamp on the entire country. You can treat them kind of as they're inside of the EU. So that's fine. That's kind of almost where the US lives at the moment. And then there's 2 levels with appropriate safeguards and derogations for specific situations, what I'm not going to talk about, where you can have big piles of contracts and technical measures to kind of make do in with processing in a country where it's not good enough by itself. That's not what I'm going to talk about. I'm going to talk about how the US fits in that second category, and especially for you also, what technical measures are relevant to maybe work around some of the legal inadequacies that might be there, legal risks. So the US has kind of a weird construct where they're kind of not exactly adequate. What does it mean? Well, they have had a series of special programs. It's kind of an opt-in program for organizations, so they can say, yeah, we are part of well, first Safe Harbor, then Privacy Shield, and then Data Privacy Framework. And organizations that opt in are considered like good enough, and they are bound by special oversight and special protection rules. But the situation is kind of unstable. So pre-GDPR, we had Privacy Shield. On the timeline, like pre-GDPR is to the left of the screen. And then, let's start with Safe Harbor. Safe Harbor was a program from 2000 to 2015. And Max Schrems, like a privacy lawyer, brought a court case forcing the EU to basically take down the approval of the Safe Harbor framework. They fixed that with Privacy Shield a short while after 2015, and Privacy Shield carried over into the introduction of the GDPR. And then there was a big case called Schrems 2. That's the same Max Schrems, who said, yeah, there might be some improvements, but the problem is more structural. You can't fix it with you can't basically opt into more protection to protect you against intelligence services in the US. That's not how that works. So Schrems won again. So in 2020, Privacy Shield failed. And from that day, there was no adequacy-like mechanism in the US. And that was actually enforced. So Uber got a fine of 290 million euros for the period of somewhere in 2021 to 2023 for no adequate measures for data transfers. Like for me personally, Uber did way more than basically any other organization in a similar situation. But Uber got a fine. I expect them to fight this, but so in the end, the fine might disappear or be way less in practice, but this was the base fine. And the infraction ended when the data privacy framework started. So that's where we are now. There are some people who believe that the reason why basically Safe Harbor and Privacy Shield failed is still not resolved. You still have intelligence services that you really can't protect against with an opt-in framework like this. So looking at the history, I might, I can imagine why people say, yeah, you might not be able to trust data privacy framework for much longer. But right now, we live in a situation where the DPF is valid. So we must acknowledge data transfers to the US under the DPF is legally good. We can't say you're not allowed to do that because we think DPF will be invalidated. You might disagree with the actual risk in practice, but legally it's still valid. And it's unknown if or when DPF will be invalidated. And try to put bets on it, but it's really hard to predict. I think the important question is, do you have enough time to take new measures when DPF is invalidated? So for example, in 6 months, some court says, yeah, DPF is not valid anymore, and the European Commission pulls the plug. Can you maybe switch vendors the next day? Or do you need to prepare right now for that when it happens in maybe 6 months, maybe a year, maybe never? So I would say prepare for the possibility, at least have backup options. But maybe important, if we say right now it's good enough, that's because we have to accept this. I can't predict the future. So what do we see in practice? Because like the legal status of DPF was one thing, but we also see people from organizations. I think that this is the remark I hear the most. Luckily not from our customers, but from people elsewhere. Like, yeah, I use AWS, but I just select the EU data center, so there's no transfer of personal data. That's way too easy. And often it's just not true. But if you believe this, from the outside, it's really hard to check. I can maybe see AWS is used in the infrastructure, but I can't really see how it's configured behind the screen. So yeah, we set a checkbox in the admin interface, so everything is fine. It's a really easy thing to say to the outside. Please don't check any further. I don't trust this. So what do we see in practice? When doing our work, we have kind of like a mental model of how we look at these services that mostly fits the stuff we look at. We have some like office environment, laser pointer doesn't work, like your desk with emails, photos, whatever, documents, like the work you actually do. And it's mostly the content. Almost everybody looks at the content because that's the bulk of the data. What we see is also there's functional data. For example, when I make a video call, it's just like the network traffic going back and forth over the internet. That's not really like, it's not only the content that's in the traffic, but it's also traffic metadata. When am I calling? Who am I calling? That's like functional traffic that just happens to be there because you use the service. And there's also diagnostic data. So all kinds of logging, whether it's like security logging or maybe developers putting like debug statements in the code to collect like, do people click this button? What's the response time when this feature is activated? Stuff like that. That can also contain personal data. So that server location button, choices like that, often focus on content. And people mostly don't discuss functional and diagnostic data. So that's where we see a lot of risks. And often in the documentation, in the small print, it just says, yeah, that button guarantees, for example, that your VM is actually located in that data center. But it mostly doesn't explicitly say, but it doesn't protect network traffic, logging, stuff like that. You have to dig deep in fine print, and it's often not explicitly documented. So transfers can be hidden. I have a few quotes. I don't expect you to read them all. Basically, the cooperation of data protection authorities, the EDPB, the European Data Protection Board, has written all kinds of documents also about transfers, where they explain these kinds of issues for everybody to at least have some common feeling of what do we need to deal with. So they give a really useful example, like keep in mind that remote access from a third country, for example, in support situations, that might also be transfer. So you say, I put my server in an EU data center, but there's still US tech support employees, or maybe from another country. If there's an issue, they can log in, check stuff out, hopefully fix it. That can still be a transfer if the tech support processes the personal data in your servers. Also important, often you have an entire, like basically a tree of sub-processors. So you have the big cloud vendor who has some companies who they, for example, for support, they hire in different countries, different organizations, and they hire subcontractors. So you have a huge like tree structure of sub-processors, sub-processors, so that can get out of hand really quickly. These are two things that are really hard to deal with and even like map out what's possible. We have sometimes like technical solutions for the first. You can build in guarantees like only have support staff from the EU respond to my tickets, but then you don't get like the follow the sun support. So these can get uncomfortable. Yeah, if there's an emergency, please wait until like 9 o'clock on a weekday. And if it's the evening or the weekend, yeah, tough luck, you wanted EU-only support. So that's uncomfortable. But it can be dealt with if you're in a, like, if you don't have a fully EU-based organization, you can manage this. Then for me, this is the fun stuff, encryption. So the EDPB gave like mostly like two clean, easy example. Like you have external backups, where they say, yeah, if you just encrypt the backups locally, and you retain full control of the keys, and the encryption is proper, you can just encrypt everything, send the backups offsite, and then when you need them, get the backups back. Hopefully you have your keys, still have your keys and decrypt. So in that case, encryption is a really good measure to basically prevent access from outside of the EU. That's fine. That's a kind of like too simple example, because yeah, backups are important, but they're like a tiny piece of the puzzle. Pseudonymization is an example. I want to name this, but in practice, I don't think I ever encountered this in the international transfer setting. But you can think of like if we send research data, like medical data, for example, to outside countries outside of the EU. You might say we pseudonymize. We might change the name of all the patients in the test data, so we can collaborate on the data without them being able to know who the data subjects are. To me, it's a quite complicated measure, not that effective, but I want to mention it. This stuff gets into the real world scenarios. Like I want to use a cloud service. I don't want to store data, but I want to have stuff outsourced to some cloud service and actually have the cloud service do useful stuff for me. Like I want to search inside the documents. I want to, I don't know, do word processing or have Excel sheets or databases or whatever. Or maybe even virtual machines. So given the context of the backups, what the EDPB said, you have to retain full control of your keys. They said, yeah, considering the current state of the art, and that's 2021, so that's like a while back, not that far. They say, yeah, but we don't see any solutions of like retaining your own keys while also outsourcing the entire processing. You kind of have to give them the keys if they want to do useful stuff with the data. This is where stuff gets interesting, because the state of the art is changing, but it's less clear, it's less obvious that that's comparable to the backup scenario. One thing I see that I'm kind of critical about is customer managed keys. That's basically you outsource everything, but you have a key server as a customer that a cloud server can talk to. So they maybe like each 5 minutes they ask like, can we have the encryption key so we can work on the data? And we promise not to store the encryption key. We just keep asking the encryption key and forgetting it and asking it again. So what does it look like? I think you have some compute server and some storage and like a safe, some kind of key server, all inside of the cloud environment. And then you have a customer talking to the entire servers. They don't see anything weird, like different from a normal scenario. But the cloud provider says, yeah, but it's a hardware security module. We can't touch the key. We just have hardware that can ask for the key, but we can't get inside of the hardware security module. Yeah, I think if you have access to that machine that can request the key, then you have access to the keys. It's a bit more nuanced in practice, but I don't think this is comparable to fully controlling the keys as a customer. So the key is in the safe. So instead of customer managed keys, you also have the entirely different scenario of customer controlled keys. So you just don't just manage the keys, you put the key server outside. You can host your own key server. If you lose the key server, you lose all your data. That's on you now. But that HSM, the hardware security module that we couldn't get into, we also can't get physical access now, says the cloud provider. For me, the issue was never physical access, but just that they can request the key from it. So the location really doesn't matter that much. But this is also a solution I see a lot. There's one advantage is that you can log access to the key maybe a little bit better and monitor how it's used. But I'm not sure how much that will accomplish. Then it gets more complicated. And this is the area where I'm starting to think, yeah, maybe that can be good enough. You have confidential compute services now. They're getting quite common in the big cloud vendors. So yeah, it's called confidential compute. Name changes slightly between vendors. It's based on like AMD secure encrypted virtualization, Intel trust domain extensions. Different platforms have different names. The concept is more or less the same. You have that HSM, but that HSM now covers both the key and the server, kind of. So it's an extension to CPUs where they say, yeah, the key is managed inside an HSM, inside the CPU, and we encrypt all the RAM. So even if you like take out the RAM and try to read it, or even if you control like the underlying operating system that handles all the virtualization, even then you shouldn't be able to access the keys. You shouldn't be able to access the encrypted virtual machine inside. To me, it's getting way less obvious that a cloud vendor can either like access or be forced to access these keys. Or the data inside. Like as long as the service that's in the encrypted, like in the confidential compute module, encrypts the data before it stores, it kind of looks secure. But the challenge is, how do I assess this? Like I'm sure you're all familiar like with how do you prove the security of your like cryptography. That's a difficult enough conversation. But how do I prove that I am actually running on the hardware that I think I'm running on when it's in the cloud and I can't touch it? And there's all kinds of solutions for that. But how do I test that it's actually secure? I don't have the expertise of the NSA, for example, to maybe find backdoors in those CPUs or maybe not, or vulnerabilities in these mechanisms. So how do I assess this? For me, this is like a really big challenge that if I have proper guarantees or enough trust in this, I can say, well, if you just use these technologies to encrypt your VMs, suddenly you can do a lot of in the cloud that you might otherwise not trust in a cloud scenario. So if you're working on stuff like this, please let me know. For me personally, I think if this stuff works as designed, it's really hard to say why it's not good enough. And we actually encountered this like in the wild. For example, we did an assessment of AWS, and I think it's called Nitro in AWS. And they have quite comprehensive like audit reports and external parties looking at the stuff that can do the security assessment better than me, but I have to trust those assessments. But you can read our assessment of it. It's published by the national government. And we do that in the form of a DPIA, so that's big report describing how the services work, what the legal context is, trying to assess like the risks for data subjects, and also a data transfer impact assessment. That's another tool. That's a giant spreadsheet with like different like analysis of the different processes happening inside of the service, and analysis of the different national laws, and kind of an attempt to model like what's the chance that maybe the NSA can access content data. So both these DTIAs and the DPIAs are published. Surf is also like one of those customers that publishes our work. We're really happy about it. So we did a DTIA and a DPIA on Google Meet for Workspace, for video conferencing, different contexts. There you can do more in encryption on the end user device, so you don't have to store much data in the cloud. That's easier. And there's a huge pile of Google and Microsoft work and assessments from us that's published by the national government. Thanks. So this was my last slide, but if you want more details, feel free to read this, ask questions right now, or if you don't want to ask questions right now, tackle me during the day. I'm happy to talk about this more. But I have time for questions now.
Thanks a lot for the talk. Do we have questions?
No questions?
This is the microphone. You just talk into the service.
Thank you for this. Was really interesting. I have a practical question. I work now in a big company on international data transfers, and we have assessed the possibility of using a trusted third party to hold our encryption keys to prevent the issues that you have outlined. But we have found that with many of the technical infrastructure that is commonly used in companies, the encryption keys are usually first created, for example, in Salesforce, and then they would be transferred to us. So we have found that we couldn't really solve the issue that the encryption key is still at, for example, Salesforce. Do you have experience with that, and do you know how to solve this?
Yes. Trying to say, I'm not sure what's public about, so I'll talk to me afterwards, but for everybody else, like the superficial answer is, it maybe doesn't really matter, like if you outsource the key server. I just purposely, like, this can also be a trusted third party. What matters is that to use the service, for example, like Salesforce, they have basically like big Excel sheets of, of data from your customers or whatever. They need to retrieve the key to decrypt the data, work on it, and then give you the results back in the web page. So it's still Salesforce accessing the keys, accessing the encrypted data, and accessing the decrypted data. So for me, it's really hard to see like how it's mostly it limits the scope of access they have, and that's really hard to assess in a way that you say, yeah, that's. But if they can only access it like for 5 minutes and then they have to renew the key, like does that help? I'm not sure. But there's lots of details to look into. But I from your question, I think you're looking at the right type of risks.
Have any further questions? I have a brief one. Where's the difference in complexity of checking, for example, that encryption is doing what it's supposed to do compared to these secure enclaves, essentially?
Oh, that's a great question. I'm not sure I have a really strong answer, but the answer I have is, like with encryption, I know like there's like a strong like academic like process of also like trying to find flaws in each other's crypto. So when there's kind of like accepted crypto standards and it's used in the way it's intended, so you keep the keys, have the right algorithms, the right key length, stuff like that, I trust that that's good enough. That if you just have access to the encrypted data, you can't do anything with it, except maybe you destroy it. So you need to have backups, but you can't modify it, you can't read it, you can't influence like bits in it or something in a useful way. So that's something I trust because of that. Like it's fully open. I know the algorithm. The algorithm has to run locally because I have to encrypt it, so I can be either audit or implement the software myself. Don't implement your own crypto algorithms, but that's kind of a manageable scenario, I think. When it's hardware, I'm not sure if there's many academic groups who dive deep into AMD hardware virtualization implementations. I'm sure there are a few, but it's way less accessible because you need both crypto and hardware expertise, and you need maybe access to like how do you debug CPUs. How do you check if it's actually, it's not physically in your control, it's in a data center. So how you check if it's the same hardware that you checked running in a data center. That's an incredibly difficult problem. So it might be solvable in the same way, but I'm not quite sure how. It's much more complicated, I think. No online questions? Oh.
for the presentation. That was really fun to listen to and interesting. I have a question actually about this control. EU has been quite consistently pushing for a backend for end-to-end encryption, currently for services, applications, and databases. So, how even effective is the customer control keys in this scenario where the information can be accessed to a hacker?
I think the honest answer is I really don't know. My frustration with the encryption backdoor debate is there's quite a few people calling for, yeah, but we still kind of need access to that encrypted stuff. And then you nerds figure it out how we can get it securely. You keep saying you can't give secure access, but you'll figure it out. You're smart. Like, I don't know how to deal with that unless there's an actual concrete proposal how to implement it. I can assess it. I don't have much trust that there's a secure way to do it. Depending on your definition of what's secure, maybe, but I really don't know what kind of solution, backdoor type solution, would be proposed here. The entire purpose of this is to prevent access from that country, even if it's, the scenario is basically this cloud stuff is in a country where they say we need lawful access to that data. And this part is in a country where they say, yeah, but your lawful access is unlawful here. That's what we need a solution for. So building a backdoor into this system to make this access possible here kind of defeats the purpose. But it depends. Like, yeah, I don't know what will be the outcome of this backdoor debate.
Thanks for the talk. So I wanted to say that when some of these, let's call them anonymous web services company, AWS, an acronym, if they happen to have a hardware security module, the scam that they pull is that they give the hardware security module, for example, to the police, and the police take it to the company that makes it, and the company that makes it has a backdoor and gives out the keys. So the original company doesn't know about the mechanics of the backdoor, so probably, but the mechanics of the seizure have leaked until now. So my question is, how can you deal with any of the services where, for example, there's a VM that's hosted that uses this? Like, on what basis is any of that trustworthy? For example, most VMs allow for being migrated between hosts, which means that the CPU registers, all RAM, everything is usually transferred, and then they can see it. And then it relies on this hardware where it's basically the equivalent of Trust Me Bro, but with a PCI device. And are any of them audited in a way where you get to see the source code or hardware so that the EU actually has a basis for trusting it, other than some companies that it's secure?
I fully appreciate your question, but I think I'm going to be a bit pedantic. I don't think access to source code is good enough, because I don't know that's the source code that's running on that specific device. So it's kind of the Trust Me Bro model, I think. That's what makes it so difficult to assess. So you either you have a choice. Do you trust the audits that they have done, and do you kind of trust the cloud vendor? That's maybe up to you. I think in most cases, working with these cloud vendors, and I'm not saying this is a thorough assessment, but I think generally these cloud vendors don't want to provide access to governments generally. So my mental model is mostly the cloud vendor wants to do the right thing, but they might be forced to cooperate. So that's maybe a slightly different, a slightly easier like mental like threat model. But I have no guarantees that that's the correct model. So yeah, great question.
Thanks a lot again for the answers. We have to move to the next talk. Let's thank
Thank you.
Floor again.